Okay, this is 8.4 notes. It's choosing a sample size, so this is actually really different than 8.1 through 8.3 where we were building a confidence interval. We are now going to focus in on finding an N, or a sample. How many samples do we need, or how many trials should we do in order to have a good practice in kind of making a statistical reference or answer. So what we need, you need to kind of decide, do you know the confidence level? How confident do you want to be? Do you want to be 75%, 95%, 99%? That is a big factor. And then you want to know your margin of error. Alright, so those are the two things we need to know or take out from each problem. Then we can calculate what we call the minimum sample size to meet our goals. So the minimum number of trials we need to make some sort of statement about what we're talking about. So it's kind of a visual what we do. Basically, what you need to take out of this slide is we're going to take this error equation. Alright, that's what we need to do. We're going to solve for n. So as long as you know your error, how confident you are, and your standard deviation, okay, we are going to solve for n and figure it out as long as we know the confidence level and how much error we need. Now, I'm not going to show you this. You guys are all very smart people. If you solve this for n, divide, okay, multiply square root n over divide e back, and then square everything, this is going to be your n formula. Alright, so we're going to use that to solve our questions in this section. So what do we basically need to do? All the givens we need, and then make sure that your standard deviation has an n above 30, or that it is an actual estimate for the actual population standard deviation. So like I said, if it's unknown, we use a previous study or a pilot study to do it, and I'll show you examples and we'll talk about it in class. The one thing to always note, and I purposely kind of put this in red, you will always have a nice round number, because you can't necessarily do a partial trial, so you need a nice round number. You will always round up to the next integer. So here is one example. Now this is the example that you will use on most problems as long as there's no proportion or probabilities involved. So a golf ball manufacturer wants to estimate the maximum distance this new golf ball is flying. So we're going to try prototype this golf ball, and before they put it out to market for golfers to buy, they need to kind of see how it goes. So some preliminary study was 36 shots. So if you took 36 shots, alright, that's going to be how many shots that you did. That's just a preliminary study. That's not the n. Okay, so big difference in that. In this study, what we wanted to take out of this study is a sample standard deviation of 11. Alright, so I know that my standard deviation is 11 yards, give or take, from our estimated mean, whatever we're going to look for. How many test shots, how many times should we hit this golf ball to make a solid estimate that the true maximum distance, if you hit it with the exact same way or with a machine, is within 2 yards? If you find that, that's your error. So if you ever see the phrase like within, that's your error. I want to be within 2 yards. My error is 2 yards, give or take, from my actual estimate. And then how confident am I? I'm 95% confident. Okay, so if you go back and look at your n formula on the previous page, you need a critical value. So the n equals is your critical score times the standard deviation over your error, and then you square it all, and that will give you your n. Unfortunately, we do not have a z critical value. So how do I find a z critical value? If you go to your z table, there's that chart. Alright, no different than we did with 8.1. And if you find 95%, the critical value is 1.96. So that is the same way as 8.1 to find that. And now we just need to dump everything into this formula. So my z critical value, 1.96, times my standard deviation. Now I put sigma here. If I do not give you the actual population standard deviation, this is where you go and find a sample. As long as it's more than 30, we're good. So 11 yards is my standard deviation. I divide that by my error, which is 2. And then I need to square it. So if you go 1.96 times 11, divide it by 2, and then square it, that's 10.78 squared equals 116.21. So they say we need 116.21 shots with a machine hitting this golf ball. Well, I can't necessarily do 0.21 of a shot. So what you need to do is always, always, always round up. So your answer would be 117 shots. Okay? So that's how many times we should hit that golf ball before we can make a statement about that golf ball. Given this information, given the standard deviation, given our error is within 2 yards, and our confidence want to be at 95%. So that's one example of, if you want to think about it kind of like a 8.1, 8.2 type section problem where you want to estimate n. So there are probably 3/4 of your problems in the homework that deal with that type of problem. If you see a proportion problem, I believe it's number 3 and 6 in your homework, don't quote me on that though, you will need a different n. Now this is also on your formula sheet, so I would take this out and try find them, but you should see these two. Now I believe this is on these formulas are on the very bottom of your formula sheet. All right? Our error formula for a proportion is your critical value times the square root of p times q over the n. Now if I solve all this for n, it's p times q, this is q, remember, times the z critical value divided by e, and you only square this part. Okay? That's if I have an estimate for p. So if there is a point estimate, then you can use this top formula. Alright? If there's not a point estimate, now sometimes we know nothing about p. We need to have the highest number possible because we don't know. Now why is 1/4 the highest number possible? We're going to assume that it's a 50-50 shot. So p and q are both 1/2. That's the highest number you can get. When you multiply 1/2 times 1/2, that's the highest number. If you would go anything different than that, it would be smaller. So they just assume that p and q are both 1/2, or they just specifically put in a 1/4. Now I'm not going to give you a problem that includes this bottom formula in the notes here. Alright? So if you read a problem and there's no p given, and they want you to find your n, or how many samples should we do, or trials should we do, you will do a 1/4, and then you would need to find the critical value and your error. Whereas in this particular problem, a bottle manufacturer wants to know the proportion of 12-ounce bottles that are defective. From last month's study, approximately 3.3% of the bottles are. Here's your p hat. They give you a previous study, okay, and tell you that. Alright? So instead of like a standard deviation idea, they have a proportion. So that's really the only thing that's different. Alright? So what you're going to need to do is figure that part out. Now, with these percentages, be careful. You need to write them as decimals. So 3.3%, if you move the decimal over twice, is 0.033. So that's going to be my p-value. Alright? If you keep on reading, and now I ask the question, how many bottles, so there's your n, I don't know n, should be sampled to pin down the true proportion of defectives to within 0.9% with 95% confidence. So confidence level is 0.95, and your error, alright, it has to be within 0.9%. Well, what's 0.9% as a decimal? 0.009. You need these as a decimal. And then you need to find your critical value. Your Z of C, or critical score, 95%. Now in any proportion problem, it is a Z-score, so you go to your Z table, that chart on the one side, 95% gives you 1.96 if you go look there. Alright, and now that you have all the information you need, we need to find that formula. So when I go back, it's a proportion. I have percentages. I have a point estimate. So I'm going to use this formula right here. So I need to find or figure out your P times your Q. So what's my P? 0.033. What's my Q? The Q is what's left over. So 0.967 times, now in parentheses, you're going to square just this thing in parentheses right here. So the Z critical value is 1.96 divided by your error, 0.009. Alright, and then you just have to multiply these things out. Now I would highly recommend doing the fraction with the square first, so you don't happen to mess things up calculating that. So if you go 1.96 divided by 0.009 and then you square it, it's 3527.64. And then if you multiply these three numbers together, you end up getting a number of 1513.45. And just like the other one, the company should use a sample size of, and that's not shots, it's not the golfing problem, this is the number of bottles actually. Excuse my little error there. How many should you use? You need to round up. So it's 1,514. Alright? So bottle manufacturer wants to know the proportion. You are given the point estimate, which is why you use the P times the Q. If I would not have given you this number right here, let's say that just wasn't in the problem at all. All it said is they want to know it. How many bottles should be sampled to pin down this number? What would be different then is you would go 1/4 times the 1.96 over 0.009 squared. That would be the only thing that's different if I did not give you your point estimate at the beginning. If I give you the point estimate, then you use the formula that I use right over here. So that is the idea of finding your sample size or choosing a logical sample size. In class tomorrow, we will work on this homework problem and fill in any questions that you have. I hope you guys have a great day.